This is the video for reviewing session 6 homework freefall and a little bit of kinematics. So let us go ahead and start with problem 1. So pennies dropped from the top of the front of Fort Collins High School and takes 1.58 seconds. Again, it says how long it takes, and it gives you a unit of seconds, so that's going to be time to hit the ground. Calculate the velocity in meters per second after 1.1 seconds of free fall, and calculate the velocity at impact in miles per hour. I should have double checked this. Don't worry about the miles per hour crap. That's on me. I'll write a note in there. Okay, so there's a couple things here. We also know for all these 5 free fall problems, if acceleration of the falling object is going to be negative 10 meters per second squared, because it is in free fall, it always is. They also say they drop the penny, so that means V naught is going to be 0. So for this case, actually, we got kind of 2 pieces of information here. So my time is not actually going to be 1.85. My time is actually going to be 1.1, because one of the questions was, what's the velocity 1.1 seconds after it starts to fall? So in this case, I do not have delta x or delta y. I do not care about delta y. So I'm going to use this equation here. So I'm going to be doing v equals a times t plus v naught. And this one, I mean, I really don't have to do much to solve it. It's 1.1 times negative 10 is negative 11 meters per second. The sign should make sense because the object is falling downward. Now, I will go ahead and, like, the velocity impact would be, you would just do the exact same problem. You would just replace the 1.1 with 1.85. And then that would be negative 10 times 1.85, which would be negative 18.5 meters per second. I apologize for the meters per second. Oh God, and feet. I did not double check this worksheet well. Guys, if you want to really take the negative 18.5 meters per second and convert into miles per hour, use Google. I do not need you to do those conversions. I just reuse this worksheet without double checking that I hadn't made changes, and that's on me. All right, problem 2. I drop a watermelon from the top of one of the tower dorms. It takes 3.34 seconds to hit the ground. Calculate how tall the building is in meters. Don't worry about the converting into feet thing. Okay, so it takes 3.34 meters to hit the ground. Again, it's dropped, so V naught is going to be 0. Acceleration is going to be negative 10 because we're in free fall. Anytime we're in free fall, an object is freely falling, its object is going to be negative 10 meters per second squared. And we are looking for how tall the building is. So I want, you know what, that's my mistake. So I get for doing this late, because I forgot I need to make this video. 3.34 is time, not displacement. Your displacement is in fact what you are looking for. So we don't have V, we don't want V. So this will be the equation that I will select here. So delta y in this case is what I'm searching for, equals V naught times T plus 1/2 A times T squared. So to go ahead and solve, 0 times 3.34 is 0, plus, let's see here, let me grab my calculator, because I do not know 3.34 squared off the top of my head. 3.34 squared is 11.156 times negative 10 times half. Gets you plus negative 55.78. And well, that's what delta y is. So the building is 55.78 meters tall because you fell a distance of 55.78 meters. That's falling means what the negative indicates. All right, for problem 3. We got you're walking along in Paris along the Eiffel Tower, suddenly croissant smacks you on the head. In retrospect, that just feels racist. And knocks you to the ground. From your handy dandy tourist guidebook, you find the Eiffel Tower is 30.5 or 300.5 meters. Now I'm going to go ahead and make this negative because we're dealing with the croissant, and the croissant or croissant is falling 300.5 meters. So if it's going 300.5 meters below where it started, its displacement should be negative. It's falling, so we're going to just say A is negative 10. Calculate how many seconds the croissant is dropped before it hits you in the head. Again, it's dropped here, so V naught is 0. And so we don't care about V, so we're going to use the same equation we used for problem 2. So we got delta Y, which is 300.5 equals V naught T plus 1/2 A T squared. So when I go to solve this, I've got negative 300.5 equals negative 5T squared, because 0 times T is 0, and 1/2 times negative 10 is negative 5. So I'm going to divide both sides by 5, or by negative 5, and this is where the sign really pays off, because if you had not done the sign correctly, then you would have wound up with taking the square root of a negative number. Now you've got imaginary numbers, and everyone's having a bad day. To get rid of the squared, we take the square root of both sides, and you get square root of 60.1 is 7.75 seconds. Now, technically, yes, it's in the square root, so you should have to decide if this is a positive or negative number. Time is always positive. If you wind up with a negative time, you have done something very, very wrong. Problem 4 says, during the last part of your European vacation, you're heading out on the beach on the Gold Coast of Spain. Blah, 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 blah. A large glob of seagull poop hits you in the face. You estimate the velocity at 98.5 meters per second, because, you got to distract from something from the fact that you just got hit in the face with bird poop. I'm also going to note that because the bird poop was falling towards you, its velocity was towards the ground, which indicates it should be a negative velocity. Acceleration is going to be negative 10. And once again, we have a case where V naught is 0. The review assignment you guys are getting today should not always have V naught being 0. How high up was the seagull? So where did you get bombed from? So in this case, time is the variable we do not have and do not want. So I'm going to go ahead and pick this second equation, or this third equation down here. So I've got V naught, or V squared equals V naught squared plus 2 times A times delta Y. So to solve this, I'm going to go ahead and take 98.5 squared. So in this case, it did not matter that I made my sign negative, because the squared takes care of that. But sometimes it will, and it's good to be in the habit. 9,702.25 is negative 98.5 squared. 0 squared is 0. Minus 20 delta y, because 2 times negative 10 is negative 20. So since the 0 just goes away, because who cares about subtracting 0, I can just go ahead and divide both sides by negative 20. And I get that delta y is equal to negative 485.11 meters. Again, the negative makes sense. So you got dive bombed from about half kilometer up. Problem 5. If you were to throw a large log over the edge of the Grand Canyon and it took 5.65 seconds, 0.65 seconds to hit the ground, again, it's dropped, so that's going to be 0. Acceleration is going to be negative 10 because it's in free fall. What is the velocity of the log? And calculate the distance of the fall. Again, please ignore the feet. I apologize for that. You should never need to do those conversions. That's dumb. So Right. We want both of these, so just pick one to solve for first. So I'm going to go ahead and just solve for v first. Doesn't matter which. So in this case, delta y is the one that at this particular moment I do not care about. So I've got v equals a times t plus v naught. Again, negative 10 times 5.65 is very straightforward. It is negative 56.5 meters per second. Okay, cool. That's part of the reason we use 10 instead of 9.81. Now I can go ahead and solve for part B. Again, the order here doesn't matter. So now I want delta y. I can use any of these equations at all, or I can use any of these two equations here because they both have delta or displacement in them. Now, for the sake of this, I'm going to go ahead and use this equation right here. There are two reasons I'm doing it. Number one, it is already set equal to displacement. And if the delta x versus delta y thing is throwing you off, they mean as the same thing. We're just talking about vertically instead of horizontal. But so it's already set equal to displacement. So I don't have to do a lot of algebra. So I'm picking it for that reason. Number two, if I used the third equation, I would get the right answer, but it would require me to use the velocity I found previously. So when in doubt, it's a good idea that if you can avoid using answers you just found yourself, then you shouldn't. Not for any physics reason, it's more of a testing strategy reason of if you screw up one part, you'd rather it not take you down for the second part. That's all. But there's do whatever you want. You just be confident you got it right. All right, so we got delta y, which is what we're looking for, equals v naught t plus 1/2 a t squared. Yeah, I realize I could have written in the 5.65 here for t, but again, we're multiplying by 0, and multiplying anything by 0 is 0, so that entire term goes away. So what we have is delta y equals, oh, I forgot the squared up here. Don't forget the squared, that's a very common mistake. 1/2 times negative 10 times 5.65 squared, and I'm just going to throw all that into my calculator. Not a lot of algebra to do here. So I got half times negative 10 times 5.65 squared, and that gets me negative 159.61 meters. Again, that's in meters, not in feet, but yeah, same thing. All right, moving on past the free fall problems, on to number 6. Indy 500 race car velocity increases from 4 meters per second to 36 meters per second over 4 seconds. What is the acceleration and how far does it travel? So again, pick one of these. It's going to be acceleration because you need acceleration in all of these equations. So right now, I don't care about delta x we're back to. So actually, let me just go ahead and fix that really quick, since now we're not doing free fall problems. Give me 1 second to fix that up. Excellent. Okay. Okay. So for problem 6, going back to this, it was you started at 4 meters per second, you went to 36, you did so in 4 seconds. We want to find both of these. All right, so because again, all these equations have delta x in them, or sorry, have a in them, I have to find a first. That means that this is the variable I'm going to ignore for a moment. Ignoring that variable means I'm going to use the equation that does not have delta x. So v equals a times t plus v naught. I'm going to go ahead and subtract the 4 over. So that's 32 equals 4a. Divide both sides by 4. And 32 divided by 4 is going to be what? 16.8. So 8 meters per second squared is the acceleration. Now that I have that, I can go ahead and find the displacement. Use any equation you want. I'm going to choose to do this one right here because, well, it's already set equal to delta x, and I feel like it. So we got delta x equals v naught times t plus 1/2 a t squared. This is where it's very important to pay attention to your sign on acceleration. In this case, it's positive, so it doesn't matter. But in the future, this equation in particular can get you in trouble. So we got 4 times 4 is 16, plus 4 squared is 16, times 4 is going to be 64. Because it's half times 8 is 4, times 4 times 4. Basically, it's 4 times 4 times 4. 16 plus 64 is going to go ahead and give you 80 meters. So that is how far the race car went in that time. Problem 7. Golf ball rolls uphill towards a mini putt hole. It leaves the club traveling at 2 meters per second and experiences an acceleration of negative 0.5 meters per second squared. What will be its velocity after it's been rolling for 3 seconds? Delta x is the variable that I don't care about, so I'm going to pick the equation that does not have delta x in it. So v equals a times t plus v naught. So half times negative 3 gives you negative 1.5 plus 2 gives you half a meter per second. Moving on to number 8, we have a airplane starts from rest and accelerates at a constant 3 meters per second squared for 30 seconds before leaving the ground. How long was the runway and how fast was it going when it lifted off? Again, what order you do this in does not matter. So when we say what variable do you not have and don't care about, just pick one of these two. So either this one or this one, pick one you don't care about. I'm going to choose to not care about, let's not care about v. Why not? Let's solve for delta x first. So if I don't care about v, I'm going to use this equation here, and that's going to give me delta x is equal to v naught t. I'm just going to drop that whole term because yes, there is time. I should put this in here, but again, 0 times 30 is just going to be 0, 0 plus 0, anything plus 0 doesn't care. So that whole term goes away when v naught is 0. My acceleration is 3. And my time is 30. So delta x is equal to 1/2 times 3 times, let's see, 30 squared is going to be 900. So that's going to equal 3 times 900 is going to be 2,700. Half of that is going to be 1,350 meters. And then for the other part, if I want to find V, I can do this one. I could also do this one for fun if I felt like it. But I'm just going to go ahead and do it down here because I don't want to take the time to erase. So V is going to equal A times T plus V naught. So 3 times 30 is going to be 90 meters per second is the takeoff velocity of this airplane. Problem 9. Over a period of 15 seconds, the plane changes its velocity from, okay, we'll do one with the unit conversions. Just know I'm never going to actually assign one of these. So, so here's the thing. You can actually do this in kilometers per hour. It doesn't matter what your unit is, as long as it's consistent. So it goes from 250 to 150 kilometers per hour in 15 seconds. So the trick is, instead of 15 seconds, I'm going to take that 15 seconds and divide by 3,600, or divide by 60 twice, because 15 seconds divided by 60 gives me minutes. Divide by 60 again gives me in hours. So I can say that this is all done over the course of 0.004 hours. And that's fine. You can do this all in kilometers per hour and hours, and get acceleration in kilometers per hour squared. That is absolutely no problem. So here's the thing. What you want is delta x. What you don't care about is a. The problem is has a, has a, has a. So we have to find a first. So I'm going to start with this equation because it doesn't have delta x, and right now we don't have delta x. And I'm just going to go ahead and say v equals a times t plus v naught. So I'm going to subtract over the 250. So negative 100 equals 0.004a. Divide both sides by 0.004. And negative 1,000, or negative 100 divided by 0.004 gives you an acceleration of negative 25,000 kilometers per hour squared, which is a stupid unit, but I don't feel like converting the kilometers per hours into meters per second. Now we can use this equation and solve for delta x by saying delta x equals v naught times t plus 1/2 a t squared. Trust me that that's 0.004 squared. I realized I was running out of room and needed the space. So I'm going to take 250 times 0.004, and that gives me 1, plus negative 25,000 times 0.5 times 0.004 squared gets me negative 0.2. So I traveled 0.8 kilometers, or 800 meters. And finally, hopefully without the stupid unit conversions, problem 10, a snowmobile reaches a final velocity of 22.5 meters per second after accelerating at 1.2 meters per second squared from rest. How long does this take? Don't care about delta x. Here's my equation. So v equals a times t plus v naught. So 22.5 equals 1.2 t. Divide both sides by 1.2. And you get 22.5 divided by 1.2 is 18.75 seconds is equal to time.